We're gonna look at graphing equations, specifically lines, but what we're going to talk about here applies to other types of functions as well. Um, so we've already talked about how you can make a table of values and graph it that way, but we're going to look at what if I want to graph a function using the x and y intercepts. So sometimes, if you can figure out where the graph hits the axes at, it can determine where the graph can be drawn, especially if you know like the general shape. So, like I said, we're going to focus mainly on linear equations, lines, but this applies to any type of situation. So to find the x-intercepts, these occur if you think about every point along the x-axis. They all have a y value of 0. So what we're looking for is where is the y value 0. Now, notice we're using function notation, so we don't have y, but remember f of x acts like y does. So we want to say, I want this function to be equal to 0. What does x have to be? Add 8. 8 equals 3x, divide by 3. Now I get x equals 8/3. Or if I want to graph this, maybe I want to say 2 2/3. So when x is 2 2/3, the y value of the answer would be 0. So what I've done is I figured out if I want an answer of 0, what value do I need to start with? Y-intercept. What I'm going to do is I'm going to plug in 0 for x. So what happens when I do that? I get 3 times 0, which is negative 0 minus 8, which is negative 8. So when x is 0, y is negative 8. And now I'm going to graph these things. And I'm going to not go, I'm going to count by 2's on my y-axis. So I don't have to draw this too big. So 0, negative 8, but I'll count by 1's over here. About 2 2/3. And like I said, I know this is a line, so I can draw my line like that. So I can do that for more complicated type of equations. The problem is right now we haven't kind of reviewed how to solve more complicated expressions. But let's say I was doing absolute value. We've talked about that. So let's say I want to graph y. Again, I'm not going to do y functions, right? So f of x equals the absolute value of x minus 2 minus 3. Okay, so to find the y-intercept, that's usually the easiest one. You just make x 0 and see what happens when you do that. So 0 minus 2 is a negative 2. Absolute value of negative 2 is positive 2. So 2 minus 3 is negative 1. So we have a y-intercept at 0, negative 1. To find the x-intercept, I want to make, again, f of x or y 0, and I want to solve that problem. So I'm going to add 3. 3 equals x minus 2. And then notice absolute value equation. So remember, we usually get 2 answers or 1 double answer. So x minus 2 could be 3, or x minus 2 could be negative 3. If it's 3, then x would be a value of 5, and if it's negative 3, then x would have a value of negative 1. So we have 2 x-intercepts. X is 5 when y is 0, and x is 1, negative 1 when y is 0. Now, you might say, well, hey, I thought functions could only have one answer, one output for each input. Notice here we said I want an output of 0. What is the input? Well, if you plug 5 into this problem, you're only going to get one answer. That answer is 0. And if you put negative 1 in there, you're only going to get one answer. That answer is 0. But it's okay if different x's have the same, different inputs have the same output. You just can't put a number in and get two answers out as an output. So you have to keep it in mind. When we talk about domain and range, what's input, what's output. So got a y-intercept here, got an x-intercept at -1, 1, 2, 3, 4, 5. Now we talked about in another video about absolute value. What does that look like? So it probably looks at something, like this. This is what the picture. And so if I wanted to, oops, again, okay, probably lose. It's a little something like that. Again, if I want to be a little bit more exact, I'll go ahead through and pick some more values in the middle here. But my guess is down here somewhere the v turns around. And so since I know this, what an absolute value looks like, I can run into that conclusion. All right, and then the other part of this section, we talk about the zeros of a function. Well, a zero is an x value that gives an answer or y value, right, of 0. So the y value is 0. What x made that happen? So let's say I had f of x equals 1/2 x plus 5. And I said, what's the 0 of that function? So what I want is this answer. I want to know, what do I plug in here so that when I do all my calculations, I get an answer of 0? Well, I'll just work it out. I'll say, let's set it equal to 0 and work it out. So half of x is -5, so multiply both sides by the reciprocal, 2/1. So -5 times 2 is -10. So that is my 0. In other words, this is actually the coordinate for the x-intercept, the x-coordinate. But these things are not the same. I want to be clear about that. Zeros is a specific number, whereas an x-intercept is a point on the graph. But you can see they match up perfectly. So on this earlier problem, these are the zeros, whereas these are the x-intercepts. Same thing on this first problem. This is the 0, and this is the x-intercept. So the 0 is just the x value of the x-intercept. They're connected. So if you know how to find x-intercepts, you know how to find zeros. So if you ever have been asked to find an x-intercept and you said, oh, my x-intercept is like 2 2/3, and you got marked off for that, and you said, why did I get marked off? Why did I have to write it this way for an x-intercept? It's because what you were really saying is, what's the 0? So if it's not asking you for a 0, it's asking you for the x-intercept. That has to be written as a point, which means it has to have an x and a y value together. Whereas a 0 is what number do you plug in to get 0 as an answer. And so, like I said, they're connected, but they're not exactly the same thing.